Right, let's look at the last question on this question paper. It says a survey was conducted among female and male learners at school about which type of cold drink they prefer. The data from the survey is represented below. This is what we refer to as the contingency table. Okay, this is a contingency table, or we know it from grade 11. So let's see what we can do. 36 plus 54, we already know this is 90. And anything? No, no, no. Oh, yeah. 120. Okay. I think that's where I can stop. Then they tell you that the events of male and preferring Jews are independent. Okay. Remember, when they are independent, it means now probability of male having male and liking Jews. Okay. It's going to be the probability of male multiplied by probability of Jews. Then they are equal. If they are independent, they are equal. In this case, you're not trying to prove. So let's see. What is the probability of male and Jews? Male and Jews, male and Jews. Where do they intersect? They intersect here. So probability of male and Jews is going to be 36 divided by total. It is 210. The total is here. And then probability of male. Probability of male is going to be this, the total of male, which is 90, divided by the total, which is 210. And let me just quickly confirm something. Just a bit. Okay. We are still moving on track. Multiply by probability of Jews. Probability of having a Jews is going to be the total line of Jews, which is E, divided by total, which is 210. So they say show that E is equal to 84. Okay, let's do that. I'm going to okay, let's say 36 divided by 210, it is equal to 90E divided by 10 multiplied by 210, 44, 100. And then I'm going to multiply everything by the reciprocal. Okay, I'm going to multiply by 44, 100 divided by 90 on both sides. When I do that, I get that. Let me just take this a little bit down here. Oh, sorry. When I do that, I get that on this other side, it's going to just be E. It is equal to, let's just quickly confirm on our calculators. Okay, 44 divided by 90 multiplied by 36 divided by 210. In actual fact, it is 84. Okay, cool. Now we have this as 84. When we have this as 84, 84 minus 36 is going to be 48. And then 48 plus what is equal to 120. 120 minus 48 is going to be 72. And then 72 plus what? Plus 54. 22 plus 54 is going to give us 126. And then, okay, everything is fine. 126 plus, let me see, 126 plus 84 is equal to 10. Okay, sharp. Now they say, calculate the probability that a female learner chosen at random from the group will like energy drink. Or the probability that the learner chosen at random will like energy. Calculate the probability that a female learner chosen at random from the group will like energy drink. Female learner chosen at random will like energy drink. So what is the intersection? It is this one. So the probability of a female liking energy drink gonna be 72 divided by 210, which is how much? Let me just quickly confirm that on my calculator. We get 23 divided by 210. Okay, I'm gonna just write it as 21 divided by 85. Okay, by the way, the reason it is 3 marks, it's because you had to find the value of A and B and all of that, okay? Yes. So you needed to find the value of A and B. But apart from that, this is the answer. Now let's move to interesting thing is, hey, read diagram. It says at kiosk, 120 people buy either a cup of coffee or a bottle of water. The chance of okay, the chance of rain on any given day it is 75%. The chance of a person buying a cup of coffee on a rainy day it is 3 times. Okay, the chance of a person buying a cup of coffee on a rainy day is 3 times the chance of a person buying coffee on a non-rainy day. Okay, so let's just do this before we go anywhere. Let's just do this. So it's either first thing first, it's either it is raining, okay? Because you need to know which one depends on which one. Because you cannot say when you buy a bottle of water, it's gonna rain or no rain. When you buy coffee, it's gonna the weather, you buying a coffee or a bottle of water depends on the weather. So we're gonna start with what we depend on. We depend on weather, okay? Weather if it is rainy, okay, or no rain. You refer to non-rain. Okay. So they tell us that the chance of rain on that particular day it is 75%, which is 0.75. Okay. And then this means it's going to be 0.25 because the probability is 100% or just one in terms of decimal. Okay. And then when it is rainy, it's either that particular person is going to buy coffee or bottle of water. Okay. Or non-rain, it's either you're going to buy, people are not the same. Okay. So it's either this one you're going to buy coffee or a bottle of water also. But now they tell us that the chance of a person buying, okay, let us read that again. The chance of a person buying a cup of coffee on a rainy day, it is 3 times on a rainy day, it is 3 times the chance of a person buying a coffee on a non-rainy day. So if this one on a rainy day, it is 3 times that when it is not raining of buying a coffee. I give 3x and x. Okay, and then they tell you that the probability of a person buying coffee on any given day, whether it is raining or non-raining, okay, so it's 7 divided by 2. Then let's now do the probabilities that you might have. So it's either it is raining and you have a coffee, okay, this is 0.75 multiplied by 3x. And then it's either, okay, I'm going to concentrate on only coffees because I'm giving the probability of coffee, okay? So whether it is non-rainy and when you're drinking coffee, it's going to be 0.25. Can you see where I take them? I say this multiplied by that. Similarly, it's going to be this multiplied by this. So it's going to be 0.25 multiplied by x. So these are my probabilities, outcomes, okay? My possible outcomes. Well, if you were interested in this one, you're just going to say 1 minus 3x, né? This one, 1 minus x, in case you're interested in it. This is how we would have done it. So now, they say, calculate the number of cups of coffee that will be sold on a non-rainy day. On a non-rainy day. Basically, number of cups of coffee will refer to people. Remember, they're basically saying how many people will buy a cup of coffee on a rainy day. So now let's first find the x because it's going to be important. Remember, we are given that the probability of person buying coffee on any given day, it is 7 divided by 3, 7 divided by 12. Probability of buying coffee on any given day. Probability of you buying coffee, it's going to be probability of buying coffee when it is raining, or whether it is not non-rainy, no rainy, yet you are still buying coffee. So it is the probability of buying coffee in this case, it is independent of the weather, okay? Whether it is raining or not, we are just giving the probability of getting a coffee on a just particular day. So it is 7 divided by 12. Again, and then probability of rain and coffee is this one. It's going to be 0.75 multiplied by 3x plus 0.25 multiplied by x. Let me use multiply by x, multiply to show there is a difference there. And then let's do mathematics. 7 divided by 12 is going to be equal to 0.75 multiplied by 3. It's 9 divided by 4 plus 1 divided by 4. And then 7 divided by 12 is equal to 10 divided by 4x. And then for me to find x, I'm going to divide by 10 divided by 4 or multiply by the reciprocal. Okay, I'm going to say 7 divided by 12 multiply by 4 divided by 10. So x is something like 7 divided by 30. But now the question was not find what one. The question was calculate the probability of coffee. Okay, calculate the number of cups of coffee that will be sold on a non-rainy day. So if this is the probability of a person getting coffee, I just need to multiply by the number of people and then I'll see. Okay, so I'm going to say number of cups of coffee on a non-rainy. It's going to be equal to the probability of getting a coffee on a non-rainy, it is 7 divided by 8. Multiply by the number of people that we have, it is 120. The number of people that we have, it is 120. Then 7 divided by 3 multiplied by 120. This is going to be 4, and then this is 28. Remember number of coffee? Sorry, not number cup of coffee. Remember cups of coffees should match what the number of people. Like if a person buys one, then it means it's 1 cup of coffee. Blah blah blah. So yes, it was like that, guys. It was like that. Okay, interesting. 11.3 says 8 runners compete in a race where there are no tied finishes. Bongi and Andrew are 2 of the competitors. Okay. 11.3.1, calculate the total number of possible ways in which the 8 runners can finish the race if Bongi finishes in a position immediately after Andrew. So we want Bongi to finish in a position immediately after Andrew. So we want Bongi to finish in a position after Andrew again. So in whatever possibilities of we might have, these 2 should be Bongi and Andrew like that. But in this case, unfortunately, they could not swap. We cannot swap. We cannot say Andrew comes before Bongi. This is just fixed. It's fixed that Bongi is gonna come after Andrew. If it was not fixed, if they just said Bongi and Andrew should finish in 2 or should finish next to each other, well, then we will have said inside here, let's just add 2 factorial. But in this case, it is fixed that Bongi will be behind Andrew. And then now let's see. They say calculate the number of possible ways. So number of possible ways. Now, if we now take this as a unit, okay, if we now take this as a unit, it means we will have other 6 competitors. Remember, these 2 are now fixed plus other 6 competitors. So it means we're going to have 7 possible ways. So it's going to be BA here and then the other 6 competitors. Okay, and then remember these are of the 7th position. Okay, so we're going to just have 7 factorial, which is 50, 40. But if they said Bongi and Andrew finishes next to each other, without fixing which one comes before which one. We will have said 7 factorial multiplied by 2 factorial inside because they could change position however, but that is not the case. So we just end here, 7 factorial. Okay. Okay. So 11.3.2. Okay, 11.3.2. Okay, calculate the probability. Okay, already read that. Calculate probability that 2 or more runners will finish the race after. Okay, instead of going the other way, I'm gonna just take this manually. Let's find the possible ways in which they can we can have 2 people running after. Let's fix Andrew here and then say Bongi here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, it's either we have 2 runners here. Okay. Let's say runner 1 and 2, and then 3, 4, 5, 6. But they can also change position such that we have in the position we can have runner 1 here and Andrew, and then we have runner 2 and 3, and then we have Bongi, and then the others 4, 5, 6. Or we can have, I'm going to take this manually, by the way. I'm just starting with 2, okay, and see the possible ways in which it can happen. So it's going to be 1, okay, or it can be 1, 2, and then Andrew, and then 3, 4, Bongi, 5, 6. I want to see a pattern. Or it can be 1, 2, 3, Andrew, 4, 5, Bongi, 6. Or here, or the last part can be 1, 2, 3, 4, and then Andrew, 5, 6, Bongi. So when we have 2 runners finishing, it's going to be this part again. It's going to be 1 times 2 times 3 times 4 times 5 times 6. Well, can you see that we have how many ways? So we have 1, 2, 3, 4 ways. So we're going to say it is 6 factorial ways multiplied by 4 possible ways, I think. Okay? 6 factorial ways multiplied by 4 possible ways. Because it's either 1, 2, 3, 4. But why am I saying 6 factorial? Because it's not necessarily factorial. They are not following each other. Oh, okay. I forgot the first one. We did the first one, so it's 5. So the first one here. Okay, so it's 5. So it's going to be 6 multiplied by 5 ways, which is 8 in this case. Okay. Now, for them to have 3 runners, it's going to be, there are 6 ways again. But now, okay, there are 6 arranged. Okay, there are 6. Okay, 1, 2, 3, 4, 5, 6. But now, the question is, now that we put Bongi here, and they have 3 here, it's going to be how many ways? So I think it's going to be A, 1, 2, 3, and then Bongi 4, 5, 6. Still 6. And then I can change this one to come here and change this to come here so that it becomes 2. And then this can come here again, and this can jump here. 3, and then come here. I think this is 4. 4. I think as you increase the number of people between, this number reduces 2, and this is it will be 24, and then 6 multiplied by, let's see if I have 4 people. If I have 4 people, I can say this is now Bongi, and then 3, 4. Okay, and then I'll have, if this comes here and this comes here, it's gonna be 2, and then this comes here, and that comes the last position. It's gonna be 3. So yeah, I think the pattern is more or less like this. 18. And then let's see if it can happen that we have 5 people. Yes, 5 people are possible. 5 people are possible. 5 people are possible. So it's going to be 6 times 2 as I see the pattern. And then for this one to be the last one, 6. Okay, for Bongi to be the last one, I can have 6 times 1. Okay. No, I see here what's happening. 12 and then 6. So I can add the totals. So I can say this is 30 times 24 times 18 times 12 times 30 times 6. Okay, I can say 6 multiplied by 5 factorial ways if I see it. Let me see. 6 multiplied by 5 factorial way. 5 factorial way. It gives me 720. Let's see. I'm just 720. Let's see if this gives us 720. I doubt. No, I doubt. Okay, so it's going to be 30 plus 24 plus 18 plus 12 plus 6. Okay, I get 66 possible ways. I don't know if there is another way, but I get 66. Okay. Is it 66? Let me just check again. Let me just check again if it's 56 or 66. 30 plus this, yes, plus that, all right. Okay, okay. No, this I get 66. This is why is it minus? Oh, I get 90 actually. 30 plus 24 plus 18 plus 12 plus this is 90. I don't know how I subtracted that. This is 90. So I have 90 possible ways if I look at it like that. I'm not sure, but I think, yeah. Well, I think 90. And then let's see. Out of possible arrangement, now we want the probability. Probability of having 2 or more. It's going to be 90 divided by factorial. How many possible ways can they run 50-40? Which is 90 divided by 50-40. It's 1 divided by 56. Okay, now I get this. Okay, so yeah, I get this. If it's wrong, unfortunately, but okay, those that are watching it now, okay, this is how I would have went about it. And then, yeah, if an official memo comes out, and then I'll rectify the mistakes thereof. Okay, so yes, thank you. That's our question 11 and the completion of the paper.